The James Webb Space Telescope is finally here. It soared into the blackness of space. This event was awaited for decades. Astronomers and space fans held their breath. It represents a giant leap for science. Many wondered if it would ever launch. The journey was long and very challenging. Now, a big question hangs in the cosmos. Was this magnificent machine worth the wait? And was it worth the staggering price tag? This telescope is not just any telescope. It is a successor to the Hubble Space Telescope. Hubble showed us wonders we never imagined. Webb promises to show us even more. It will peer deeper into space than ever. It will look further back in time. It aims to see the universe's first light, the dawn of the very first stars and galaxies. This is a monumental task for any machine, a quest for our cosmic origins. The story of Webb is one of ambition. It is also a story of perseverance. Scientists and engineers faced many setbacks, budgets ballooned and timelines stretched, yet the dream was never abandoned. The idea for Webb started long ago. It was first called the Next Generation Space Telescope. This was back in the late 1990s. Scientists knew Hubble would not last forever. They needed a more powerful successor. A telescope to see the infrared universe. This part of the spectrum holds many secrets. Secrets about the early distant cosmos. The initial plans were ambitious from day one, but no one knew how ambitious it would become. The original cost estimate was much lower, perhaps around $1 billion. The launch was planned for much earlier too, maybe around 2007 or 2010, but building such a complex machine is hard. New technologies had to be invented. The mirror needed to be huge and lightweight. The sun shield had to be a marvel of engineering. These challenges led to delays. And delays always mean more money. The costs began to climb steadily, from $1 billion to $2 billion, then more. Eventually, the price tag reached about $10 billion. This caused a lot of concern. Some politicians questioned the project. They wondered if it was too expensive. The James Webb Space Telescope is an engineering marvel. Its primary mirror is a sight to behold. It is 6.5 meters or 21 feet across. This is much larger than Hubble's mirror. A bigger mirror means more light collected. More light means seeing fainter, distant objects. The mirror is made of 18 hexagonal segments. These segments are made of beryllium. Beryllium is strong and very lightweight. Each segment is coated in a thin layer of gold. Gold is excellent for reflecting infrared light. This is the light Webb is designed to see. Infrared light can pass through cosmic dust. Dust clouds hide many young stars and planets. Webb can peer into these hidden regions. But to see faint infrared signals, Webb must be cold, extremely cold, around -233 degrees Celsius. This is where the amazing sun shield comes in. It is the size of a tennis court. It has 5 layers, each thinner than a human hair. The sun shield protects Webb from the sun's heat. It also shields it from Earth's and Moon's heat. Without it, Webb's own heat would blind its instruments. The instruments themselves are incredibly sensitive. They are cameras and spectrographs. They can detect the faintest flickers of ancient light. The stakes for the James Webb Space Telescope were immense. Think about the sheer amount of money involved. $10 billion is a colossal sum. It could fund many other science projects, or address pressing problems here on Earth. This investment represented a huge gamble. A gamble on technology, on engineering, on people. If Webb had failed, the loss would be devastating, not just financially, but scientifically too. The field of space astronomy would suffer greatly. Then there was the time investment. Decades of work by thousands of brilliant minds. Careers were built around this single project. Students became seasoned engineers working on Webb. The hopes and dreams of so many were tied to it. A failure would mean all that effort was in vain. The pressure on the launch and deployment was incredible. It was a one-shot deal, no second chances. Unlike Hubble, Webb orbits far from Earth. It is at a special point called L2. This L2 point is about 1.5 million kilometers away. That is 4 times farther than the Moon. Astronauts cannot travel there to make repairs. Hubble was famously repaired in orbit. That repair saved Hubble and made it a legend. Webb had to be perfect from the start. Section 5. Stepping beyond Hubble. A new infrared universe awaits. Many people ask how Webb compares to Hubble. Hubble is an icon, a beloved space telescope. It has given us breathtaking images for decades. Webb is not meant to replace Hubble entirely. Instead, it is a successor and a complement. It builds upon Hubble's legacy, but it sees the universe in a different way. The biggest difference is the type of light they see. Hubble primarily observes visible and ultraviolet light, the same light our eyes can see. Webb, however, is optimized for infrared light. Infrared light has longer wavelengths than visible light. This is crucial for several reasons. The universe is expanding. As it expands, light from distant objects gets stretched. This is called redshift. Light from the very first stars and galaxies is so redshifted it reaches us as infrared light. Hubble cannot see this ancient light very well. Webb is specifically designed for this task. Another key difference is mirror size. Webb's primary mirror is 6.5 meters across. Hubble's mirror is 2.4 meters across. This means Webb can collect over 6 times more light. More light means seeing fainter objects. It also means seeing things that are farther away. Section 6. Cosmic Cartography. Webb's ambitious science goals. The James Webb Space Telescope has a grand mission. Its science goals are truly transformative. It aims to rewrite astronomy textbooks. One major goal is to study the early universe. Webb will look for the very first stars. These were the pioneers, lighting up a dark cosmos. It will also search for the first galaxies. How did these infant galaxies form and grow? Webb's infrared eyes can pierce the veil of time. It will show us the universe in its infancy. Another key area is galaxy evolution. Galaxies are not static islands of stars. They change and evolve over billions of years. They merge, they grow, they form new stars. Webb will study galaxies at different cosmic epochs. This will help us understand their life cycles. How do supermassive black holes at their centers form? How do they influence their host galaxies? Webb's observations will provide crucial clues. It will trace the cosmic web of galactic structures. Star and planet formation is also a prime target. Stars are born in dense clouds of gas and dust. These stellar nurseries are opaque to visible light. Section 7. Early light dazzling sights Webb's first triumphs in pixels. The anticipation for Webb's first images was immense. In July 2022, the first full-color images were released. They were breathtaking. One image was Webb's first deep field, showing a galaxy cluster called SMACS 0723. The cluster's gravity acts as a cosmic lens, magnifying distant galaxies. Webb revealed thousands of galaxies, some seen for the first time. These images were packed with scientific data. Webb was already pushing the boundaries of observation. Another stunning result was the Carina Nebula, revealing hundreds of young stars. Webb also demonstrated its power in exoplanet studies, capturing a detailed spectrum of WSP-96b. The spectrum showed water vapor, clouds, and hazes. This was a remarkable demonstration. Section 8. Grounded in reality, Webb's limits and lifespan. While Webb is a revolutionary telescope, it has limits. It is not an all-seeing eye and cannot answer every question. Its primary strength is infrared astronomy. Other telescopes like Hubble excel in different wavelengths. Webb is part of a toolkit, complementing other observatories. One significant limitation is its lifespan. Webb is designed for a mission of at least 5 years. Its operational life is limited by fuel. Current estimates suggest Webb could operate for 20 years or more, but it will not last forever. Unlike Hubble, Webb is not designed to be serviced. Its distant L2 orbit makes astronaut visits impossible. If something major breaks, it cannot be repaired. This made the initial deployment critical. So far, all systems have performed remarkably well. Section 9. An unfolding saga why Webb continues to inspire awe. So, was the James Webb Space Telescope worth the wait, and worth the immense cost and effort? Based on its performance and discoveries so far, the answer from the scientific community is a resounding yes. It has opened a new chapter in astronomy. It is already transforming our view of the cosmos. From the dawn of time to the atmospheres of alien worlds, Webb is delivering on its ambitious promises. It is a testament to human ingenuity and our unyielding desire to explore. This telescope symbolizes more than just science. It represents what humanity can achieve when we work together across nations, when we dedicate ourselves to a grand vision. The challenges were enormous, almost overwhelming. Yet perseverance and innovation triumphed. Webb is a story of hope and determination. It reminds us that big dreams are worth pursuing, even when they seem almost impossible. The quest for knowledge is a powerful motivator. As of today, May 21, 2025, Webb is busy. It is scanning the heavens day and night, New data flows back to Earth continuously. Scientists around the world are analyzing it. They are making new discoveries almost daily. We are no longer holding our breath anxiously.